As we begin Unit 11, which is our last unit for the year, we are looking at some different ways to solve a quadratic equation. In Unit 10, we learned how to factor a trinomial and then set it equal to 0 and find the factors. If a trinomial can be factored, that is the easiest and quickest solution to get to where we need to go. However, sometimes we cannot factor a trinomial and we will need another method. So in Unit 11, we're going to be looking at some different ways to solve. We will start 11.1 with just remembering how to factor. So the good news is the first lesson, pretty basic review. The objective will say, I will be able to factor and solve trinomials to find the x-intercepts. Once you have your objective done, go ahead and move on. You're going to write down the following notes. Here's our steps. The first thing is, please make sure that the equation has been set equal to 0. If there is a number besides 0 on one of the sides of the equal sign, you will need to add or subtract to move it over. Once you have it as a trinomial all on one side of the equal sign, we'll go back to multiplying a times c. Just to make sure we understand this direction, that would be if we had 2x squared plus 3x minus 4. We would multiply a times c, which is 2 times negative 4. Well, a times c is negative 8. So we will have to find two numbers that multiply to negative 8. Then we will find the factors of AC, which we just found, negative 8, that add to the middle term b. So step 2 is when those same two numbers must add to the middle number, b. So we have to find two numbers that add to 3. We would then rewrite b using those factors. This is where if you are a factor by grouping person, you would write the 4 terms out. You would have 2x squared plus the 2 terms that you found minus 4. Or if you're a box person, this is where you would put first term first box, last term last box, and then those 2 middle terms would go in the missing boxes. Once you have done that step, step 4, you will find the GCF of each side. So if you're a factor by grouping, you're pulling out of each pair. If you're using the box, you're pulling out the GCF, remember, of each row and then of each column. You're pulling them out. Make sure that when you're done that the signs match. That is very, very important. Once we have that done, we put the factors together. So for example, if we were to have come up with 2x minus 2 and maybe x minus 2. Once we have those, in 10.2, you learned how to set those factors equal to 0. That is the next step. You would set each one of those equal to 0, and you would solve it. Those would be the two x-intercepts of the parabola. So this is a nice review of what we have done before. Once you have those steps written down, we're just going to simply practice. I hope you notice in this first example, it is already in factored form. We already have x minus 2, x plus 3, and it's set equal to 0. So we simply write those as two separate equations, and we solve them. I'm hoping by now that you've remembered we use opposite operations. So if I want to get rid of the minus 2, I'm going to add 2 to both sides of the equation, leaving me with x equals 2. That means one of my x-intercepts occurs at the point 2, 0. The other equation, if I subtract 3 from both sides, we will see that x equals negative 3. That means the other x-intercept occurs at negative 3, 0. Just to give you a visual, this is telling us how wide our parabola is. We have an x-intercept at negative 3 and an x-intercept at positive 2. Now in Unit 10, we did learn how to find the vertex and see that it is right in the middle of the two x-intercepts. And I'm estimating about how low it goes because I'm not being exact here. Because the idea is we're trying to just see how wide the parabola is. These x-intercepts that we just found tell us the width of our parabola. Now, if the equation is not already factored for us, it might look like example 2 where it's in standard form. That means we have the x squared term plus the x term plus the number equal to 0. This is where we have to factor it. We need to find the two numbers that multiply to 49, and the same two numbers must add to the negative 14 in the middle. We have been factoring quite a lot since before spring break, so I'm going to go a little quickly through this. If we are a box person, we are going to go first term, first box, last term, last box. In order to fill in these two missing terms, I need to find two numbers that will satisfy. I need to find the two numbers that multiply to 49 that add to negative 14. Well, I know 7 times 7 is 49. 7 plus 7 equals 14. But in order for it to be equal a negative 14, we would need to make them both negative 7. So that means negative 7x goes in each one of the boxes. Now I'm going to go across both columns, both rows. The top row, they both share an x. The bottom row, they both share a factor of 7. Straight up, they both share an x. Straight up, they both share a 7. What I need to figure out is my signs now. The only way to make it multiply to a positive 49 at the end is for both 7s to be negative, because then that matches the blue terms also being negative 7x. So what I have now is I have x minus 7 on top, and I have x minus 7 going down the side. This is actually the exact same binomial. So if I visualize, even writing it twice, I'm hoping you will see we will get the same answer. If I add 7, I will get x equals 7. I'm going to get the same answer over here as well because it's the exact same equation. That means this parabola is only going to have one x-intercept. That means it's going to sit on the x-axis. So for example, if we look where x is 7, that means the parabola sits on the x-axis right at 7. So just to clarify, because we got the exact same binomial, we got the exact same answer, that means there's only one solution, one root. The root or solution is the x-intercept right on the x-line at 7. So let's look at our next one. This is the one that tends to throw us the most. If we go ahead and go right to the box, remember first term, first box, last term, last box. Now I need to figure out what two terms go in the middle. I need to find two numbers that multiply to a times c, which is 6, and my same two numbers must add to the middle term b, which is 5. I'm going to go with negative 2 and negative 3 because that multiplies to a positive 6 and that adds to a negative 5. 6 and 1 will not work because of the signs when you get to the addition statement. So if we have negative 2x and negative 3x. Now we're going to simply pull out our common factors. Straight across the top row, they share a factor of 2x, across the bottom a 3. Straight up an x, straight up just a 1. In order for the signs to match, we need to make both numbers negative so that it multiplies to that positive blue 3. So the two binomials we have are 2x minus 3 and x minus 1. We're going to set each one of those equal to 0. And then if we go to solve it, we will add 3 to both sides. That is 2x equals 3. Divide by 2. So the first x-intercept is at 3 halves, 3 over 2, which is the same as 1 and a half. Finishing our 1 over here, we just have to add 1 to each side, and we end up with x equals 1. That's it. We have solved the quadratic equation. This is working because we were able to come up with two numbers to make this even. You will see later in the unit that sometimes it does not work. There is not a pair of numbers that work. And that's when we will have to learn how to complete the square or go to the quadratic formula. But the good news is for today, for 11.1, everything should be able to be factored. I'm hoping when you look at this equation, you notice something interesting. It is not set equal to 0. It is set equal to 47. We need to move the 47 to the other side. Well, the opposite of a positive 47 is a negative 47. So I'm going to rewrite it as 3x squared minus 10x minus 8 is equal to 0. So remember, if we want to move a term from one side to the other side, we do the opposite sign of either adding or subtracting. And since it was positive, we did a negative or a minus sign. So now, whether you're a factor by grouping or a box person, let's go ahead and factor this. I'm going to go with factor by grouping this time just to be different. I need two numbers that multiply to negative 24 that will also add to negative 10. 6 and 4 sound good, but there's no way to get that to multiply to a negative 24. I'm going to go with negative 12 and positive 2. So now if I go with factor by grouping, I'm going to do 3x squared. Instead of minus 10x, I'm going to write it as minus 12x plus 2x. Notice that's in blue because it matches the two numbers that we found. And then it ends in minus 8. So all I did was rewrite the minus 10x as these two terms. So now let's go ahead and group them. The first pair of numbers, the terms, they share a factor of a 3 and an x. If I divide that out, that leaves me with x minus 4. The second pair, they share a factor of 2. If I divide that out, that leaves me with x minus 4. One of the reasons I do like factor by grouping is you know you did it correct when one of the binomials repeats. So x minus 4 is one of our factors. The stuff we pulled out, the factors, is our other one, 3x plus 2. So now we have factored, and now we set equal to 0. We're going to take our 3x plus 2 equal to 0, and our x minus 4 equal to 0. We should be fairly proficient at solving these equations. We add or subtract first, and then we divide. So our first x-intercept occurs at negative 2/3, so that's between 0 and negative 1. The next intercept, if we add 4 to solve, we end up with x equals positive 4. So again, I went a little quick with solving. However, we have been factoring, this is the third time we've seen this, since before spring break. All right, that is it, ladies and gentlemen. As you look through your notes, if you feel comfortable with each one of these examples, that you can factor it and set it equal to 0, and you can meet this objective that you're able to factor and solve to find the x-intercepts, you are done.